Hi everyone. So today I saw a little question called value binary tree. So a value binary tree defined using three properties below. The first is that the left subtree must have smaller values than the node. And the second property is that the right subtree must have a greater value than the node. And finally, both left subtrees and the right subtrees must be binary search trees themselves. So this means the subtrees or subtrees must also be binary search trees. Okay, now let's look at some examples here. So you see the first example, we have this root 2, and the left node is 1, the right node is 3. You see the left child is smaller than this root, and the right child is greater than this root, so this is obviously a binary search tree. Now, the second example, so maybe use drawing here to help you understand. Okay, you see the root is 5, right? And the left child is 1, so y is smaller than 5. This condition satisfied. And however, you see the right child is 5, is 4, and 4 is not greater than 5. Actually, 4 is smaller than 5. So this condition is not satisfied, and we have to return false, indicating this is not a binary search tree. Okay. Now, there's also one thing to note is that an empty tree is also a binary search tree, as we learned in algorithm data structure. So our intuition is simple, which I'll explain later. We'll start as minus infinity as the left boundary and infinity as the right boundary. Then we'll gradually shrink the boundary and check if there's any value violation for the left subtree and right subtree. So now let's dive into the coding part. And I think it will gradually make sense. So the first thing is to start with our boundary, and we'll call the helper function. So let's say the helper function will have the root, will have the left boundary, which we will initialize later. Now the right boundary. Now let's solve the helper function itself. This helper function will have this kind of variable. The first thing we have to check the helper function is that if there's no root, then we have to return true, right? And the second thing, if there's value violation, we have to return false. And after that, we check the left and right subtrees and final return. Okay. Now finish coding comments. Let's write the code itself. So no root, we return true. And if the value violation, so what is value violation? Well, if the value is not violated, we'll have the root val between the left boundary and the right boundaries, right? So just right here. And if you add a node here, this means the value is violated. In that case, we have to return false. Okay. And after that, we just check the left subtree and the right subtree. Let's call the left subtree condition as result left. Call this helper function, passing root of the left. And then, because we are checking the left subtree, the left boundary should be same, but the right boundary should be shrink to root of L. And now for the right subtree, that's called the result right. We call this helper function, pass this right. And since we are checking the right subtree, the left boundary should be root of L. And the right boundary should be as it is. Okay, finally, we have to check if both the left subtree and right subtree satisfy condition, then it's a binary search tree. Otherwise, if either of these does not hold, we have to return false. Okay, so we write it in a Pythonic way, return result left and result right. Now the final thing, since we are finished with the helper function, we have to check the initial condition for left boundary and right boundary in our main function. So the safe way is to starting with float minus infinity for the left boundary. So at the beginning, it will be smaller than any values. And also for the right boundary, starting as plus infinity. So the beginning will be greater than all values. And finally, let's submit the result to see it works. Okay, I think the internet connection is not stable today. Uh, uh, Let me check if the solution really works. Okay, you see the time capacity memory usage of this solution is not bad, and the code is short and easy to understand. If you like this video, please subscribe to my channel, and see you next time. Thank you.